Hey class, today we are going to learn something very interesting. Tell me, did you know that coal can appear red? Yup, you heard me right. It appears red as well as purple at the nanoscale.
What's nanoscale?
Nanoscale refers to structures having dimensions measured in nanometers, and a nanometer is equal to a billionth of a meter. If a man were a nanometer tall, it would take him 24 years to walk across a dollar bill. Now we know how small we are talking.
Whoa!
Let's go. Gold, being a metal, has a sea of free electrons that are excited by the electric and magnetic field of the incident light, and as a result, the electrons start moving. The cations try to pull back these electrons, due to which the electrons start oscillating with a specific energy. This oscillation is called as plasma oscillation. We know that photon is the particle name for light wave. Similarly, plasmon is the particle name for plasma waves. When the frequency of the light wave is equal to the natural frequency of the oscillating electrons, a resonate condition is established, and the oscillation of electrons is called as surface plasmon resonances, which result in unusually strong scattering and absorption of light. When surface plasmon resonance takes place in nanometer-sized structures, it is called localized surface plasmon resonance, which is a non-propagating excitation of conduction electrons of metallic nanoparticles smaller than the wavelength of light. The entire assembly of electrons is polarized and the charges alternately accumulate on the opposite sides of the particle.
Miss, can I take this for my girlfriend?
Aww.
Too small for her to see.
For gold nanoparticles, the resonance falls into the visible region of the electromagnetic spectrum. The color of nanoparticles highly depends on size and shape. For small gold nanoparticles about 30 nanometers long, the localized surface plasmon resonance causes absorption of light in the blue-green portion of the spectrum, while the red light is reflected, giving a rich red color. As particle size increases, the absorption wavelength shifts to longer wavelengths. Red light is then absorbed and blue light is reflected, yielding a solution with a purple color. The stained glass, which you see in the structures dating back to the medieval time, owe its beauty to the amazing optical properties of metal nanoparticles.